Good evening, everybody. Peter O'Driscoll here again. This is our second week of the Project Management Professional and Certified Associate in Project Management preparation classes. Tonight we're going to cover scope management and time management. So let's move ahead with the slides. Before I do that, actually, can I just ask you to hold off putting in questions into the webinar question box, because it's quite difficult to be able to answer all these questions that come through so quickly. The preference is that if you could put them into the discussion board, and I'm more than happy, either myself or Margie would be happy to answer any questions that you have. So we certainly will answer them. The other thing that I would like to do, instead of putting questions into those box, the question box or the chat box, is that you actually put in the answers to the sample questions that I'm going to put up a little bit later on. There'll be 3 sample questions associated with scope management and 3 sample questions associated with time management. So if you don't mind following that basic instruction, that'll be fantastic. So let's move ahead and we will look at what we covered last week, which was the introduction. We looked at 2 what's called knowledge areas, integration and stakeholder management. And this week we're going to cover scope and time management. And following weeks, these are the other knowledge areas that we will tackle. So we're in week 2 and we've got 2 more weeks to go. Week 5 is where you will do your open book online test, but you will probably realize that at the moment we have a weekly test that we would like you to do, and that weekly test will indicate the progress that you're making and that you're ready to sit the final exam. Okay, I mentioned that we're going to do scope management, time management, and we will then each of the topics we'll finish off with a few sample questions, the type of questions that you could be asked in either of the CCPM or the PMP exams. We have reading material and exam preparation notes at the end. Let's carry on with the slides. So collecting requirements for both product and project. So product is what the end result from the outcome from the project is, and the project scope is what you produce as you're going through the project. Things like the project management plan, the schedules, everything that the project management team actually produce to enable the product to be delivered to the end customer. So what's involved in scope management? Essentially, we've got 6 processes, and those processes come under 2 of the process groups: planning and monitoring and control. So they're the 6, and what I'm going to do is move on to the next slide, and that's going to cover each one of those in a little bit more detail, and then we will discuss it in further detail. The plan scope management looks at you decide how you're going to manage and collect scope and manage the scope of the project as you go through to the final delivery. Collect requirements involves defining and documenting the stakeholder needs to meet the project objectives. You define the scope, which involves creating a scope statement, and that includes a detailed description of the product and the project, describes the deliverables and work required to carry them out. We create what's called a work breakdown structure, and we'll define that in a greater detail, but a work breakdown structure essentially represents what's in the project or the scope statement. We move on then into the monitoring and control, and one of the processes there is what's called validate scope. So the validate scope means that we will validate and approve the project deliverables against the baseline. That's the customer who does that. So we gain acceptance from the customer, and once we gain acceptance, obviously the customer is happy to take it on board. And the last process is control scope. And that involves looking at scope and making sure that we don't allow scope creep to occur. If it does occur, if we need to change the scope, we should do it in a formal manner, and we get any change requests that arise from formal requests approved before we accept it and move further into accepting the changes and locking it into the project. Moving into the first of those in a little bit more detail, we have plan scope management, and plan scope management has 2 subsidiary plans. The first one is the scope management plan, and the second one is the requirements management plan. And I highlighted a few minutes ago the two components: the product, which is the features and functions of what you're trying to deliver, and the project, which is the work to be undertaken to create the product, and that's what the project management team essentially undertakes. So what's in the scope management plan? It's how the scope will be defined, developed, monitored, controlled, and verified. How we were going to create our work breakdown structure, and as we go through the project, how we're going to maintain that work breakdown structure. We determined the criteria for formal acceptance. So how will the customer know that the deliverable is acceptable? You need to maybe ensure that the details are in your scope management plan, so that when it comes to actually validating the scope, the customers will comply with the agreement that has been made. How are we going to raise change requests? So when we have a request to make changes to the scope of the project, what do we need to do? The requirements management plan sets out how we're actually going to gather requirements, how the activities will be planned, tracked, and reported, and we have a number of tools and techniques that are included in PMBOK, and there are 11 that I'll just list. I'm not going to go through them, but you'll see that there are 11 suggested techniques and tools in PMBOKs. What categories of requirements do we tackle, and how will the requirements be changed if we need to change the requirements? So collecting requirements, then, it's the input into the next two processes. That's define scope and create your work breakdown structure. So we collect requirements from our stakeholders. Who are our stakeholders? All those people that we have highlighted in our stakeholder register. We discussed that last week. Different types of requirements could be business, stakeholder, solution, and they could be functional or non-functional. We have transitioned. What happens when we're moving from where we are into the new whatever the project's delivering, what project deliverables, and what project requirements and what quality outcomes do we expect. Requirements must be baselined, unambiguous, measurable, etc. All these things are appropriate when we're determining what the requirements are and putting some substance around them. What normally happens is when you're gathering requirements, you have the users, the stakeholders suggesting we want this and we want that and we want the other. Requirements, it allows the stakeholders to determine what they would like. However, when we move on to the scope statement, we will determine which of those requirements we're actually going to deliver. So how do we gather requirements? Well, there's all these different ways of doing so. Everything from interviewing to brainstorming, nominal group techniques, etc., etc. All these things are ways and means of gathering requirements. And the output from this exercise is what's called the requirements documentation. It lists all the requirements, and there will be a traceability matrix. Traceability matrix allows you to say, well, okay, these requirements tie back to the original goals of the organization, and then we will use that traceability matrix as we go through the into the scope, and we will further when we're going to check out and test the requirements that we've actually gathered and we've delivered against those requirements. Moving into the next process, which is define scope. We now have the requirements, so which of those requirements are we actually going to deliver to the customer? So it's a detailed description of the product and project requirements that we're going to deliver. We will do a product analysis which converts the high-level description into tangible, verifiable deliverables. So we actually have a good idea exactly what we're going to deliver from the project, and that's one of the important aspects of the scope statement. So in the scope statement, we have a scope description, we have scope deliverables, acceptance criteria, what is the criteria the customer is going to determine whether it's acceptable or not, any assumptions, constraints, exclusions. All these things should be part of the scope statement. You should only include the work that's part of the project and no other work, but it's important that you include all the work that's required from the project. Moving on to the next process, and that's creating the work breakdown structure. Now, work breakdown structure is like anybody who has some knowledge of a manufacturing environment. We have what's called a bill of material. and a bill of material takes the manufactured product that you're going to produce and breaks it down into all the raw materials and higher level work in progress until you get to the final item. So a work breakdown structure is basically the same thing, except the main difference between a bill of materials and a work breakdown structure is, notice over the left-hand side we've got project management deliverables. These are all the deliverables that are included in the overall project that form part of the work breakdown structure. All the other deliverables essentially go to make up the aircraft. Actually, it's not quite true. There are other things like training, but the actual aircraft itself, you've got the component parts there at the bottom. Note that these are all at a higher level. We haven't said how we're going to actually deliver those. Another example is a software product, and we look at project management again. What are the product requirements? Detailed design, construct, integrate, and test. This level here of the work breakdown structure is up to you to decide which is the appropriate way to depict this particular work breakdown structure. So the key areas regarding work breakdown structure, it is an extremely important element in project management planning. PMBOK says it should exist for every project. You start at the very top. This is what we want to deliver. What are the lower level elements or components of that? And you keep breaking it down. And the lowest level of a work breakdown structure is a work package. Later on, we will break down that work package into activities, but that's not part of the work breakdown structure. When somebody says, can you give me a work breakdown structure, there is a school of thought. Well, essentially the school of thought it comes from Microsoft Project. A Microsoft Project calls the schedule the list of activities a work breakdown structure. PMBOK does not, and the ISO, the International Standard for Project Manager, does not recognize a work breakdown structure as a list of activities. That's a very important thing to know. So when somebody asks you for a work breakdown structure, do make sure that you understand whether they want a PMBOK version of the work breakdown structure or a non-standard Microsoft Project list of activities. So the work breakdown structure identifies all the work to be performed. If it's not in the work breakdown structure, it shouldn't be in the project. Work packages are charged to control accounts for cost management. So actually you can go higher than the work packages. You can actually have a higher level in the work breakdown structure when you're gathering costs that end up in your general ledger. Again, that's just something for financial people. How do you gather costs? How do you recognize where the costs are being expended in your project? The work breakdown structure is just numbers and titles. There is what's called a work breakdown structure dictionary. The dictionary is almost like a work instruction. It has things like statement of work, defined deliverables, responsible individuals, the milestones, everything that is required for people to go off and do the work. So that's the work dictionary. The work breakdown structure is a tool to assist a project manager in decomposition and does not show dependencies as you will find in a network diagram or in a schedule. So just highlighting again, the PMBOK talks about creating a work breakdown structure. It's under scope management. The activities necessary to produce the deliverables are defined under defined activities process, which is under time management. However, PMBOK says, look, you may be doing all these things in an iterative fashion. You may be drawing up your work breakdown structure, your activity list, your work breakdown structure dictionary. All these things are happening at the one time. So really, it's not a must do this first, must do this next. There is a situation where you're actually undertaking this work in an iterative manner. Scope baseline. So the scope baseline includes the scope statement, which we have previously brought together. It includes the work breakdown structure, which is the hierarchical decomposition of the scope, and then we've got the work breakdown structure dictionary, and that includes the detailed description of all the various aspects of each work package in the work breakdown structure. Important that you know what the scope baseline is. Just to emphasize what the word baseline is, a baseline is a point in a value that's put in place at a particular moment in time. So essentially, when you've finished the initial planning of your project, you end up with baselines. You end up with a scope baseline, you end up with a cost baseline, you end up with a schedule baseline. All these things are measurements measurements that you can monitor against and decide whether you are working towards your scope, you're exceeding, or you haven't quite met your scope requirements. Moving on to the next process, and this is to be found under the monitoring and control. Validating scope. So validating scope involves the customer agreeing that what has been produced from the project is appropriate and acceptable. Don't forget the acceptance criteria has been defined in your scope statement. You may find the customer says, hold on a second, that's not quite what I asked for. But I think you did well, let's agree to disagree. I do need a change. Let's agree to the change, whatever it costs, whatever the work involved, whatever extra resource you need. Let's draw up an agreement and we will put that into a change request. Sometimes people will call that change request a variation. So at the end of the day, the scope is the project. So the client is focused on what the end result is. They don't look at all the other elements and all the other knowledge areas that are the concern of the project managers. The second process under monitoring and control that relates to scope is control scope, a very important part of project management. So you're checking to make sure that you're working towards the scope baseline. You look at to see if there are any variances between the scope baseline and what's actually happening. Make sure there are no unauthorized changes. So we have two concepts associated with unauthorized changes. Well, maybe more, but these are two well-known ones. Scope creep. And scope creep is where the customer says, oh, can you just add this little bit of functionality here and this little bit of functionality there? And let's say you've got a software product and the tester is, oh yeah, sure, we can just do that. And the tester has a few little changes here, there, and everywhere. But before you know it, 4 or 5 days has passed by while the developer is putting those extras the customer asked for. But they haven't been agreed to, that who's going to pay for that? That just delays the project by another week. So the customer has to pay their developer, or at least the vendor who's undertaking the work has to pay their developer. So essentially the vendor loses in that situation. Gold plating is similar but slightly different. Gold plating is where the developer decides off their own bat. Now, wouldn't the customer really like this if I put this little flashy light here and I put this logo here and I put the this link here? Again, we've got the situation where we're finding that the scope has surpassed the original baseline, and the question is who's going to pay for that. So the project manager, unless they control all these potential scope creep situations, gold plating, etc., can lose control over the project, and all of a sudden the project manager is wondering why the project is overpassing the original agreed baseline, scheduled baseline, why it's costing more. All these things are very much part of controlled scope. So controlling scope is a bit like expectation manager. Make sure that you, the customer, knows what to expect, and we keep managing the expectations. That falls in under stakeholder management and stakeholder engagement. Now let's, essentially we've gone through all the processes that are involved in scope management. So what I'm going to do is to test out your knowledge in this subject, either from what we've done, or maybe you might have be able to answer this question from a logical point of view. So the first question is, and what I get you to do is, I'm not going to do the poll like we did last week. What I'm going to do is to get you to put into your chat or your question box what you consider the answer. Is it A, B, C, or D? So before you do that, let's just read out the question. The following is an example of a constraint associated with project scope that limits the team's options in scope definition. So what do we mean by a constraint? A constraint is something that the project manager has to work within and realizes that they haven't got a complete open slather, that, for example, the budget is a constraint, the time schedule is a constraint. So the first answer to that one is a defined budget of any imposed. I think I've virtually given the answer, and I can see all the A's coming up. So plenty of A's, the odd B. Yeah, good, thank you, that's good. So you're reading much faster than I am. So, okay, so that's the first question, and let's move on to the second question. Then the second question, the following is true about a work breakdown structure. The work breakdown structure is another term for the bar chart or Gantt chart, or it is each descending level of the work breakdown structure represents an increasing detailed definition of the project work. It's C, which is work not in the work breakdown structure, is usually defined in the scope statement of the project, and finally the work breakdown structure shows only the critical path activities. So we're getting B as the answer to that one. Gee, that's fantastic. The number of people who have got the right answer is fantastic. If you haven't got the right answer, don't worry too much. It's just means that maybe you have to spend a little bit more time in catching up with your knowledge. The next question is, which of the following is true about validate scope process? It is the process of formalizing acceptance of the completed project deliverables. It's not necessary if the project completes on time and within budget. It occurs primarily when revisions or changes are made to project scope. Or finally, scope verification is primarily concerned with correctness of the deliverables, whereas quality control is primarily concerned with acceptance of the deliverables and meeting the quality requirements specified for the deliverables. We're getting a lot of D's there. Actually, there's quite a mixture. A's, D's, etc. So the correct answer is validate scope is a process of formalizing acceptance of the completed project deliverables. You remember what I said? It's the second last process in scope management. It's where the customer will validate and ensure that they're happy with the delivered product. The important point though is that the criteria, the acceptance criteria, needs to be laid out in the scope statement. So the customer can't be coming up with their own rules when they come to validate the scope. Notice down at D, we're going to come across scope verification. That's part of quality control. And scope verification is something you do internally within the project team, and the project team will verify before they hand it over to the customer to validate. Okay, we're now moving on to time management. And I'm just looking at the time, and it seems to be going just nicely. We've 25 minutes passed by. Time management is a little bit more, although scope management is extremely important, it's there's one or two aspects of time management that's going to take a little bit more time to explain. Okay, the schedule is the key to producing a good schedule is good planning. A schedule is a vital integrated component of a project management plan, but a schedule is not a plan. How often do you go into a company and the person who is given the role of looking after an element of work, which could be described as a project, they will use Microsoft Project to draw up a schedule, and then they will describe that as the plan. That will be produced, and anytime anybody wants to find out what's happening with the project, the schedule is what's going to be used to determine how things are going. Yeah, we've done this, we've done that, we've done the other. The unfortunate thing about the schedule is part of time management. For project management point of view, there are 9 other knowledge areas that need to be applied to a project. So the important thing is to realize that a schedule is not a plan. So when somebody says, here's my plan, you have to be diplomatic, but really at the end of the day, you've got to say it is not a plan, it is a schedule. So time management covers plan, development, manage, execute, control of the schedule. There are 7 processes, and an activity is a component of work performed during the project. So these are the 7 processes. Under planning, we've got 6 of them and only 1 under monitoring and controlling. Okay, so what are the different processes? Very briefly, the plan schedule management. It's a methodological statement saying how we're going to go about planning the schedule. We plan, and then how do we manage the schedule? We define the activities as the first step in terms of planning. We do that by taking the work breakdown structure, looking at the deliverables, and decomposing the work breakdown structure into actions, specific activities that need to be performed to produce the deliverables. So remember, the work breakdown structure is a deliverable hierarchical breakdown, whereas the time management helps you to define the activities. Actually, don't be too surprised. This is just an aside. In the PMBOK edition 6 won't be out for another year and a half, but don't be too surprised if you see defined activities going under scope management. It won't change the way that you do the work. It will definitely not be part of a work breakdown structure, but it might be considered as part of scope management as opposed to time management. One way or the other, it is part of time management in edition 5. We move on to sequence activities. So we now know what work we need to do, and then we have to determine what sequence and in what order do we need to do these activities. So we identify and document the relationship between the project activities. We estimate the activity resources. Okay, so what resources do we need to undertake these activities successfully? So there's going to be people, there's going to be materials, equipment, supplies, all these things we need to determine and assign them to the activities. We estimate activity duration. So how long does it actually take to do the work? So we estimate the work periods needed to complete individual activities with the estimated resources. So when do we start? When do we finish? And we develop a schedule. The schedule is the end result from all this work, and the schedule essentially gives you a list of all the activities in sequence with their durations, the resource requirements, and any schedule constraints to create the schedule. There are a whole lot of things that come into play when you're drawing up the schedule, things like managing your risks, determining what contingencies or reserves that you need to build into your schedule to take account of any potential risks. The other thing we'll be talking about is estimate activity duration. I have a little bit of a slight discussion or disagreement with PMI about the steps that are involved. Once we are up and running with the project under the monitoring and control process group, we have monitored the status of the project in terms of the schedule. And if we are going off track, we may have to raise change requests to bring it back on track again. Sorry, not to bring it back on track, but to recognize the fact that we have to spend some extra time on the project for various factors, various reasons. We may have had some more wet days on the construction site than we had anticipated. So the assumption was it was going to be 20 wet days, but it turns out to be 40. So the customer will have to recognize the fact that extra payment has to be made to the contractor. So this is just a list of the steps to create a schedule, identify all the activities, determine the logical order, assign resources, estimate the time required for that activity. We compare the schedule with the imposed dates. Imposed dates, somebody says the Melbourne Cup is going to take place on the first Tuesday of every November, and it's going to take place at 3 o'clock. That is an imposed date, it's imposed time, so you've got to meet that. It is a deadline that has to be complied with. We consider the project budget and cash flow, quality, demands and risk factors when we're drawing up our schedule. So this is my little bone of contention with PMI. They talk about estimating duration, but I believe what you've got to do is to estimate the resources and the effort, and the duration then will be a calculated figure. So if you're using a scheduling tool, you might want to put in the effort that it takes to do some work. If it takes 4 days to do something, but you have 2 people doing it, okay, that's only 2 days. So the duration gets calculated. Moving on to the first of these processes, and we look at it a little bit more detail. So the plan schedule management sets out the schedule baseline to be, how the baseline is going to be determined and how it's going to be managed once we're up and running with the project. So managing and controlling the schedule. So the inputs into this particular process includes the project management plan and the project charter, and the output is the schedule management plan. A schedule is I said it's not a plan, but it's a very important part of the project management plan. Moving on to the next process involves breaking down the work packages into activities. You determine the effort associated with each activity. So this is where you determine the effort. You assign attributes to these activities. You apply milestones. There are tools and techniques that PMBOK suggests, and that's the decomposition of the work into lower and lower level activities. We have what's called rolling wave planning, and rolling wave planning says, look, we don't know everything about some of the project aspects that will not be tackled for another few month or two. So let's not worry about the detail. We will do the detailed planning associated with the work that we are doing over the next month or two. We will take expert judgment to determine how much effort is involved, and therefore helps us to define the activities that are needed to do the work. So the output from this particular process is an activity list, activity attributes, and milestone list. Just to go back again, what is a milestone? A milestone is essentially a particular point in time that the project manager has determined, is a point that you look back and you say, oh good, we've reached this milestone, maybe we should celebrate. Or we've reached this milestone, it's the end of a stage, let's move on to the next stage once we've got approval. So a milestone is a particular point in time, and it has zero duration. So there is no time associated, there's no resources associated with the milestone. We move along and sequence the activities by identifying the logical sequence of work to get the greatest efficiency given all project constraints. One of the things that's very important as part of scope management and then subsequently in drawing up your schedule is, can we do this better? Is there a better way to do something? We move along to using some of the tools, which includes a precedence diagramming method, and that's one of the tools that we use to build a project schedule, a network diagram. And this graphic displays a sequence in which activities are to be performed. There is another tool called the activity on arrow. That's very rarely used, and I'm not going to discuss it today. So sequence activities, the first thing we need to think about is the predecessor and successor activities. Which comes first and which comes second? And we link those two activities together in a way that we recognize which is the successor and which is the predecessor. We have various relationships. Can we start this particular activity before we finish the previous one, or do we have to finish the previous one before we start the next one? Do we have to finish the previous one before and also finish the second one at the same time, so be both heading at the same direction at the same time? Maybe we can start an activity at the same time as we start the predecessor, or we may be able to start the predecessor before we finish, before you can finish this predecessor. So the successor can start before you can finish the predecessor. So we have different types of dependencies. There are mandatory dependencies, discretionary dependencies, and external dependencies. So what's a mandatory dependency? Well, a mandatory dependency might be you want the cement to dry before you can move on to the next stage. You don't have a choice. A discretionary dependency says, will I paint this particular room first or will I paint that room? You have a discretion to decide which activity takes first. An external dependency can be something that's dictated to you outside the project. We have a concept called lead and lags. So a lead is where you actually have a situation where the activity will have a time that's described as a lead, and that means that you can actually start something before the predecessor finishes. So you've got this much time. And the lag is where you have a gap between the start time and the finish, or sorry, the finish of one task and the start of a next. Good example of a lag is waiting for the cement to dry. So you can't start the rolling of the cement or putting some stakes into the cement before it's actually dried. So that's a lag, and the lag might be 2-3 days, whatever it is. So this is an example of a network diagram. And notice the beginning and the end, and all the different tasks are represented by letters of the alphabet. And notice the acronyms there. The SS start, so you can start B and C at the same time. Is it mandatory to start it? Well, it depends on the particular. Sorry, just slipped my mind. The dependency type that we're talking about. Moving on to the next the next process, which is estimate activity resources. So what resources do we need to undertake the work? So there could be human, material, equipment, supplies. So you may have an activity that doesn't require any human intervention. It could be done by equipment. But it's more than likely that if there's material involved, there'll also be humans involved. What type, quantity and characteristics of each do you want? And important considerations, particularly for humans, but can also happen when you're ordering equipment or supplies, is the calendar. When can these people be available? What leave do they have? The risk register is important. What risks have we got? Do we need to make contingencies and ensure that we apply any understanding of our risks to the quantities that we require? And we need to consider the activity cost estimates, because if you find that maybe the cost estimates are a little bit high, you might go back and revisit your resources, and you might say, well, okay, instead of getting an expert consultant, let's see if we can get somebody internally to do this work. So the output, initial output from this is a resource breakdown structure, other than having the resources identified. Moving on to the next process, and this is the one where I feel I have a little bit of a disagreement with PMP. So the suggestion here is you determine the time to complete activity, whereas I suggest it is a calculated, so long as you determine what the effort is and the resources to apply. It requires an estimation of the amount of work effort required to complete the activity and the amount of available resources estimated to complete the activity. So PMP, this is my comment here, suggests that duration is estimated, should be calculated from effort and resource units. What are the tools and techniques associated with estimating? Expert judgment, that means that you can, a good guess based on your expertise. Analogous is how long did the last one take? We built a hospital, so a similar hospital, it might take us the same length of time. Parametric, how long did it take us to put in 100 bricks? Let's say it's going to take, we need to put in 200 bricks, how long is it going to take those 200? 3-point estimate, you take the most optimistic, plus 4 times the most likely, add the most pessimistic, divide all that by 6, and that gives you an estimate. And that's called the 3-point estimate. You've got what's called group decision-making techniques, and reserve analysis, which I mentioned is often determined based on your risk factors and deciding what contingency you're going to put into your reserves. One of the things I notice is that these are all estimating techniques, but a very important one is bottom-up estimating, and for some reason or other PMP has overlooked that. We develop our schedule, which is the outcome from all those activities. So you enter the schedule activities, durations, resources, resource availabilities, and logical relations into a scheduling tool. Nowadays, you wouldn't do this on a spreadsheet, or you wouldn't do it manually, because the tools are there to enable you to do this work very effectively. It generates a schedule module with planned dates for completing the project activities. It's an iterative process. You look at the schedule, oh no, we don't want to end up spending 2 years on this. We're going to have to start doing things in parallel, and we're going to have to try and speed things up by getting additional resources. So this involves schedule network analysis. Tools and techniques: schedule network analysis, critical path method, critical chain method, resource optimization techniques, modeling techniques, leads and lags, which you discussed. I'm going to talk about some of these in a few minutes. Schedule compression means that you're heading towards a deadline, and you feel that you need to compress the schedule, because if you don't do that, you're not going to meet the deadline. The scheduling tool is also one of the tools and techniques. Okay, let's talk about, we're going into critical path management, and that essentially determines which are the critical activities that we need to undertake that ensures that we're going to get the project completed in the shortest possible time. So for each activity, critical path method determines 4 dates and a number. So it's the early start date for each activity. So what's the earliest we can start this activity? What is the earliest finish? What is the late start, and what is the late finish? And we then calculate from these figures the float or the slack. The starting point, though, is the duration. We need to put in the duration. And we head in this direction, which is called the forward pass. We work out the earliest start date. Then we look at the duration, and we can determine what the earliest finish. And then we work backwards. At the end of the project, this is when we're going to complete the project. Let's work backwards. When is the late finish for this activity? When is the late start? And you keep going back, and we look at an example of that in a few minutes, and we then work out what the slack is, or the float. Okay, so the critical path, again, this is the same thing. You add the start plus duration plus the finish, and the highest number wins when there are multiple inputs. So you move on to the one activity onto the next. So you add these early start plus duration plus finish, and that gives you the highest number, and that moves on to the next stage. You work backwards as well, so add the finish plus the duration plus the start, and the lowest number wins when you've got multiple inputs. So in other words, there may be one or more activities associated with this one here. So here's an example, and what I'm going to do now is to leave this up on the screen. Forget those ends, it's just a mistype. And I'm going to look at another slide which is going to show us how the calculations are determined. What we got here are the various activities, activity A, B, C, D, and what is the predecessor? Well, we're starting. So A is the first activity there, and B happens to be the first activity. But before we can do C, we must have done A. Before we can do D, we must have done A and B, etc., all the way through. So how long does each activity last? Well, it takes 4 days to undertake activity A, takes 6 for B, etc., etc. So let's look at I better get back down to the slide that I had. Bear with me for a second. All the way down here. So here is the critical path calculations, and if we call up the other slide that I've got here, which is the actual example that we're going to do, and the example is, if I just move a few things around here from my point of view. Okay, so here's the critical path. You've got activity A, B, C, D, and E. You draw this up based on your activity and your predecessors. So you see that the start is here. A and B start at the same time. You then start C after A. You determine that D can start after you've done A and B. So we haven't actually got a connection there between A and B. So this, I haven't done this 100% correctly, but just ignore that. E must have E and D before it can start. Both of those need to be finished. So you build up a diagram like this that will actually give you the dependencies and the sequence of activities, and you end up with the finish there. So all the durations are in place. So what we're going to do now is to say, what is the earliest start date? So the earliest start date for activity A is day 1. Now there are different ways of reflecting this. Some people say you should put day 0 there, and then your calculations seem a little bit more sensible. But what PMBOK is suggesting is you start at the beginning of day 1 and you finish at the end of day 5, or the end of day 4, sorry, which is, so there's the start, there's the end. So how do you get 1 plus 4 should give you 5? But because I said 0 is not there, you put in 1, therefore you put in a minus when you add 1 plus 4 minus 1 gives you 4. Move along to the next one, which is you start on day 5. So day 5 then is add the 8 to day 5 and you get 8 plus 5 minus 1 gives you 12. So we're going to work out the earliest start and earliest finish date for all of these activities, and we do that. You can see as I'm pressing my key here, the next key, it's working all the dates to the end. And the end is you expect your project to be completed on day 33. Now we're going to do a backward pass, and the backward pass says, okay, we finish on day 33. When is the latest? So the latest we can start is the latest finish is day 33, and the latest start happens to be 33 plus 33 minus 8 plus 1 gives us 26. move on to the next one, which is 33 is the latest finish date here, because we can finish both of these at the same time. But when is the latest, the latest finish, the latest start then is 33 plus 5 plus 1, 33 minus 5 plus 1 gives you 29. And we do the same thing all the way through. So we end up with the earliest start, the earliest finished, the latest start, and the latest finish in all of these boxes. So how do we calculate the float? Well, the float essentially is, or the slack, is we take the subtraction from either the earliest finish and the latest finish, or from the earliest start and the latest start. Both of these give you the same result. So let's do a calculation, and the end result goes up in here. So the first one is 0. 33 from 33 gives you 0. 26 from 26 gives you 0. Move along, you get 0. Move along 0. 1 here. We get 1 here. We get 15 here. So we got 15 days slack up our sleeve. We get 0. We get 0. Okay, so there are a number of activities that have 0 slack. Essentially, they represent the critical path. Anything where you don't have any room to play with ends up being the critical path. And that's where the project manager has got to focus their energy and time on ensuring that we stick and we work with the critical path. And they're the red arrows highlighting what the critical path is. So that is, let's go back and we go back to our slides. And we move along to the next slide. So hopefully you understand what the critical path is, and these are the end results, which should be in your slides. You need to, maybe before you look at this, go back and look at the previous slide and work at your own critical path from the figures that you're given. Now, there's a concept called critical chain project management, and the reason it's a fairly new concept, and it works on the basis that people overestimate all activities in a project. When somebody asks you, how long do you think it's going to take you to do that? You're going to cover yourself. You're going to say, well, I think it'll take 5 days, but I better cover myself and say it's going to take 7 days. So you tell the project manager it's going to take 7 days, and somebody else says, oh, I'm going to take 10 days to do this, but just to be on the safe side, I'll say 12. So the project manager gets input from all the project team, and they give these figures with an extra number of days added into just in case days. So the project manager says, now these are all the dates that I've been told it's going to take to do the work, so I'm going to have to put an extra bit onto that because I need to make sure that whatever happens, I've got a little bit up my sleeve. So the critical chain is all about trying to eliminate all this additional effort that goes into and all this additional schedule that is created unnecessarily. It's developed by Eli Goldrath in a book called The Critical Chain, which was produced in 1997. But that was developed on an earlier book that he wrote called The Theory of Constraints. And the Theory of Constraints is a production-oriented approach towards management. It focuses on identifying and relieving bottlenecks to improve efficient use of resources. So essentially what we want to do is take away all the additional estimates that people have put on their time. So a schedule method that allows a project team to place buffers on any project schedule path to account for limited resources and project uncertainties. So what we're saying is don't put the additional time on individual activities. Take all that additional time and put it into a bucket, and we call those buckets buffers. And then we will use those buffers as we need it. So it introduced a concept of buffers and buffer management, and we recognize as well that we can't do activities if we haven't got the right resources at the right time. The availability of resources will actually affect our ability to do the work when we need to do it or when we want to do it. So critical path doesn't take resources into account. If you remember when we did the calculations a few minutes ago, there was no question of availability of resources. So the critical chain does take account of resources when they're available. So what are buffers? As I mentioned, buffers are a little bucket of time that we put aside. and the buffers are there to be used by the project manager when we need to recognize the fact that people have taken more time than they actually suggested that they would take. It's a collective allowance for the possibility that any work component will take longer than estimated. Contingency and slack provisions assume that each task will take more time, so we've got to ensure that we eliminate contingencies and slack. And sometimes tasks take longer than the other tasks. Some tasks might take less, so the buffer is to be used when you think you need to use it. So the 3 types of buffers is the project buffer. It's the overall buffer for the project as a whole that you put aside. You've got a feeder buffer where non-critical paths merge with the critical chain to protect critical chain from delay. So that's a buffer that is just to make sure that your sequence of activities, there's enough buffer there for project for one activity to another. And then we've got a resource buffer. And that's a buffer that you put aside to enable you to manage scarce resources and to account for people when they're not available, and you build an extra bit of time into your schedule to take account of the unavailability. Okay, so that's essentially a quick run through critical chain. So you develop the schedule output. So the schedule output is the schedule baseline and the project schedule. We move on to the next process, which is control schedule, and we recognize deviation from plan and take corrective action. So we look at how we're going, we look at the actual time that's been spent, and we say, look, we're going over schedule, we need to do something about it. Tools and techniques include performance reviews, using project management software to help you, using resource optimization techniques, etc., etc. All these things are part and parcel of the tools of controlling your schedule. And the outputs from that is you've got work performance information, you've got scheduled forecasts. In other words, we now realize that we may take longer, or we actually think we can finish a bit quicker than we thought. Or we may have to raise change requests or variations to take account of the fact that we realize that we're not going to finish on time. We need to go ahead to spend extra time, produce extra resources, and maybe have to spend some extra money. So that brings us finally to the questions, the 3 questions that we have associated with time management. So first question is, the project time management processes include, and these are all the various processes, and have a look at those and see if you can identify which one has the correct the correct processes. So we're getting B, we're getting C. B seem to be the generally accepted. Let's keep going. Yes, plenty of Bs. So yes, B is the correct answer. So moving on to the next question. Okay, we don't need any more answers because we need to move on to the next question and find out what you think of this one. The next question then is, the duration of an activity is affected by all of the following except. Notice the word except. These are the sort of things you've got to be aware of in exam questions. So the duration of activities includes everything except, and what do you think is the except? We got D's, C's, A's, quite a good selection of answers. The duration of activities is affected by the estimated activity resource requirements, affected by the type of resources assigned to the activity, and it's affected by the availability of resources assigned to the activity. So it's affected by all these things, the duration. So using the precedence diagram method for scheduling activities instead of using critical path, that's doesn't make too much sense. So if you don't really understand what it is, it's probably the answer that you're looking for. So the final question here is, the following is true about the critical chain method, which we've just talked about, and these are the various things. Which one is the correct answer? Not an easy question. We're getting A's, D's, B's. Somebody said AS. The correct answer to this one is yes, it is a schedule network analysis technique that accounts for limited resources. You remember we said that critical path doesn't take care of critical resources, and it also takes care of project uncertainties. This is not an easy question. I accept that. It doesn't use, they use the word buffer or something like that in the question or in the answer there. You might be a little bit more clued in, and you might understand what the question is about and the answer. Okay, so that completes tonight's and there are all the answers to your questions. So if you want to do those questions again later on, and it tells you where to go in PMBOK to get the explanation and the background to those. So I noticed that I've been asked a question there. Arrest says, I'm unable to see the sample polls. No, unfortunately, the questions are hidden from you as the audience for the reason that we've decided that all the questions and the chat, any things that arise, any queries that you have should appear under the discussion board on our website. So isn't it great that we finish on time this week, and hopefully we will see you back again next week. Looking forward to that. So good night or good day. I know that there are people from all over the world attending this, and it's fantastic that we have such a wide and varied audience. So good day, good night, good afternoon, whatever time it is. Thank you for attending, and again, hopefully we will see you next week.